Okay, in this video we're going to talk about events involving not and or, and also odds. So let's go ahead and get started. It says, first of all, the probability of an event not occurring, and we've actually discussed this previously. We discovered that for any event E, the probability of E plus the probability of not E is equal to 1. So for example, it says if you draw a card from a deck of cards, find the probability that you get a king. Well, remember, it's the number of favorable outcomes divided by the total number of outcomes. So there's 4 kings out of total of 52 cards, and so that does reduce to 1/13. So if there's a 1/13th chance that you get a king, probability of getting a king, what's the probability that you don't get a king? Well, that would be 12/13. These should add up to 1. So, I mean, you could have done it more directly. There's 48 cards that are not a king out of 52, and that'll give you the same answer. All right, so it says, in general, the probability that an event E will not occur is equal to 1 minus the probability that it will occur. So let's do some examples here. Whoops. It says, use the formula above to answer each question below. If you are dealt 1 card from a standard 52 card deck, find the probability that you are not dealt a heart. Okay, so the probability that you don't get a heart, the probability of not getting a heart, would equal 1 minus the probability that you do get a heart. So that would be 1 minus, well, the probability of getting a heart, well, let's see, there's 13 hearts out of the deck of 52 cards. And so that's 1/4 when you reduce 13 over 52. So that'll be 1 minus 1/4. And so that's 3/4. Now, if you have any problems doing any of the fraction arithmetic, I would remind you to use your calculators to check yourself. All right, let's look at number 2. In fact, if you haven't already tried it, I would encourage you to do that and then watch the video. All right, so it says a jar has 4 white marbles and 3 red marbles. Find the probability of not selecting a red marble. So the probability of not choosing a red marble is equal to 1 minus the probability that you do choose a red marble. Well, let's see, that's 1 minus. Now there's a total of 7 marbles, 4 white and 3 red. So the probability that you get red, there's 3 reds out of a total of 7. And so here you would get 4/7. All right, let's move on to the next page. All right, in number 3, it says, use the chart to determine the probability that a person in this population is not widowed. So this would be 1 minus, I'll just go ahead and write this out. The probability that you're not widowed would be 1 minus the probability that you are widowed. It's not a good thing to be. That means your spouse has died. So the probability would be 1 minus the probability of being widowed, and it'd be 1 minus. Now notice in the chart, there's 14 out of 242 that were widowed. So this will be 14 over 242. And when you subtract that, you get 114 over 121. And actually, I should probably write that as a decimal. 114 divide 121. So that's about 0.94 or 94 hundredths. All right, we're going to talk about OR probabilities next. It says if A and B are 2 events the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. All right, so let's see how that works. It says if a die is rolled, what is the probability, it should say of, getting an even number or a number that is greater than 4. So the probability, the probability of getting an even number or a number that's greater than 4, well, that's going to be the probability of getting an even number plus a probability of getting a number greater than 4 minus the probability of getting a number that's even and also greater than 4. Well, the probability of getting an even number, when you roll a die, that would be 3 out of 6. The probability of getting a number that's greater than 4, well, that would be 5 or 6, so that's 2 out of 6. What's the probability that you get a number that's even and greater than 4? Well, that's getting a 6. That would be the only one, so that would be minus a 1 in 6 chance, because there's only one number that's even and greater than 4. And in fact, when you, what's that, 5, 6 minus 1, 6, you're going to get 4, 6, which reduces to 2/3. All right, I'm actually going to show you a Venn diagram to help you to see this. So let me go ahead and make myself a Venn diagram. I've got my even numbers and my numbers that are greater than 4. So even numbers would be 2, 4, and 6. Now the 6 goes in here because it's also greater than 4, as is 5. And so 6 and 5 are the numbers that are greater than 4. Notice that the 6 is in both sets. And so here's the thing. When we found the probability of getting an even number, we counted the 6. And when we counted the probability of getting a number greater than 4, or when we found that probability, we also counted the 6. So we counted it twice. And so basically we're subtracting the probability of getting a 6 out because we had counted that 6 twice. And so that's why the formula is the way that it is. Go ahead and try number 2, and then I would encourage you to look at the video. All right, it says if one card is selected from a deck of cards, what is the probability that a heart or an ace will be chosen? Well, let's see. The probability of getting a heart or an ace is going to equal the probability of getting a heart plus the probability of getting an ace minus the probability of getting a heart and an ace. Basically, wouldn't that be the ace of hearts? And so the probability of getting a heart, well, there's 13 of each suit, 13 hearts. So the probability is 13 out of 52. By the way, we want to keep our fractions not reduced. We want them to all have the same denominator so the arithmetic's a little bit easier. The probability of getting an ace, well, there's 4 aces out of the 52 cards. Minus the probability of basically getting the ace of hearts. There's only one ace of hearts out of 52 cards. So what's that? 13 and 4, 17 over 52 minus 1 is 16 over 52. And if you reduce that, that reduces to 4/13. Just divide the numerator and denominator by 4. All right, let's go ahead and move on to the next slide. So, or probabilities with mutually exclusive events. What's going on here? It says two events A and B are mutually exclusive if it is impossible for both events to occur at the same time. So here's some examples. So an example of mutually exclusive events, a die is rolled once. If event A is rolling a 3, so event A is rolling a 3, and event B is rolling a 6. The two events are mutually exclusive. See, it's not possible when you roll a die one time to get a 3 and to also get a 6. So we say they're mutually exclusive. Well, here's an example where two events are not mutually exclusive. So a die is rolled once. We're just looking here. If event A is rolling an even number, so A is rolling an even number, and event B is rolling a 4, the two events are not mutually exclusive. So is it possible to roll an even number and also roll a 4? Yeah, you could roll the 4 and then you get both. And so these are considered to be not mutually exclusive. So anytime you have mutually exclusive events, if two events A and B are mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B. So what we're missing here is the probability of A and B. But we just said that these two events cannot possibly both occur at the same time. And so this would just be 0 anyway in a situation like this. All right, so let me erase this here. So let's look at two examples here. In number 3, it says, if a die is rolled once, what is the probability of getting a 1 or a 6? Well, if you roll a die one time, you can't get a 1 and a 6. So these are mutually exclusive events. And so the probability of getting a 1 or a 6 is equal to the probability of getting a 1 plus the probability of getting a 6. So that's going to be 1/6 plus 1/6, which is 2/6, which of course reduces to 1/3. So again, I would encourage you to try the next one and then watch the video. All right, so it says if one card is selected from a deck of cards, what is the probability of selecting an ace or a jack? So if you have a deck of 52 cards and you choose one card, it is not possible to get an ace and also get a jack. They're two totally different cards. Can't do both at the same time. And so in this case, the probability of getting an ace or a jack is equal to the probability of getting an ace plus the probability of getting a jack. And so the probability of getting an ace, well, there's 4 aces out of the 52 cards. The probability of getting a jack, same thing, there's 4 jacks out of the 52 cards. So we get 8 over 52, and that would reduce to, let's see, if we divide by 4, we would get 2/13. All right, let's go ahead and move on to the next slide. So here's some problems where we kind of mixed it up. So you've got to know, are we dealing with a mutually exclusive case or a case where it's not mutually exclusive? Now I just want to say, if you wanted to be safe, remember the probability of A or B is equal to the probability of A plus the probability, of B minus the probability of A and B. Now, if it's impossible for event A and event B to occur at the same time, then this probability would be 0. So you could actually use this formula every time if you wanted to take the safe way out. But basically, if you have mutually exclusive events, in other words, the two events cannot possibly occur at the same time, then you actually only have to do just this first part. All right. Number 5. One deck is selected from a deck of playing cards. Find the probability of selecting a 10 or a face card. Well, you're picking one card. It's not possible to get a 10 and also get a face card. So the probability of getting a 10, whoops, or a face card is equal to the probability of getting a 10 plus the probability of getting a face card. Now I think in your book they might call these picture cards. Picture card, face card, same thing. So the probability of getting a 10, well, there's 4 10s in a deck of 52 cards. So 4 out of 52. The probability of getting a face card, remember there's the Jack, Queen, and King, but there's 4 suits. You got your queens, diamonds, clubs, and spades. So 3 face cards times 4 suits, so 3 times 4 is 12 out of 52. And again, since these are mutually exclusive, this is all we have to do is add these up. We'll get 16 out of 52. And if you divide by 4, you get 4/13. All right. Let's see. Let me look at... All right, the next problem here is, let's see, we have to find out what's the probability of getting an ace or a red card. Now, first of all, when you draw one card, it is possible to get a card that's red, and that's also an ace. You could get the hearts, or you could get the diamonds. Okay, so let's go ahead and do this one. The probability of getting an ace or a red card is equal to the probability of getting an ace plus the probability of getting a red card minus the probability of getting an ace and a red card. Well, the probability of getting an ace, that's 4 out of 52, plus the probability of getting a red card, remember that's half the deck, 26 out of 52. And hold on just a second here. So the probability of getting an ace and a red card, so again we have the ace of diamonds and the ace of hearts, that's 2 out of 52. So 4 and 26 is 30 minus 2 is 28. And let's see, if we divide by 4, we'll get 7/13. All right, let's move on to number 6. It says if you roll a 6-sided die, what is the probability of getting a 4 or a 5? Well, we know it's not possible when you roll one 6-sided die that you could get a 4 and you could also get a 5 in one roll. So the probability of getting a 4, or a 5 is equal to the probability of getting a 4 plus the probability of getting a 5. Well, the probability of getting a 4, remember there's only one 4 on a 6-sided die, so that's 1/6 plus 1/6 probability of getting a 5. We get 2/6, which reduces to 1/3. All right, number 7. Now this is a silly problem I pulled out of the book. I think you're going to run into one similar to that in your homework. It says, in a group of 25 baboons, 18 enjoy grooming their neighbors, 16 enjoy screeching wildly, while 10 enjoy doing both. So notice we have, it is possible for both events to occur. Notice we're supposed to find the probability that it enjoys grooming its neighbors or screeching wildly. So the probability that a baboon, that's if you select one baboon, the probability that it enjoys grooming neighbors or screeching wildly. It's going to be the probability that it enjoys, or that it's a baboon that enjoys grooming. Let's see, this takes a little time to write this out. Enjoys grooming neighbor, plus the probability that it enjoys screeching loudly or wildly, minus the probability it enjoys doing both. I'm just going to write doing both. All right, so the probability that it enjoys grooming its neighbor, well, there's 25 baboons and 18 enjoy grooming their neighbor, so that's 18 out of 25. Plus the probability they enjoy screeching wildly, there's 16 in that group out of the 25, minus the 10 that enjoy doing both. So that would be 10 out of 25. So let's see, that's 18 and 16. That would be 34 minus 10, which is 24 out of 25. Okay. We're going to go ahead and stop this video right here, and I'll do a second video to finish things up.